Hi and welcome to video 2 of linear equations and their functions. And first we're going to be looking at one-step equations. So, simple one-stage linear equations. Let's talk about those. Let's start with a simple one like we had in the previous video. 2 plus x equals 8. We have to recognise the opposite or inverse operation here is to subtract the 2. So we go through the process of subtracting 2. And we end up with x is equal to 8 minus 2, which of course is 6. There are lots of ways we can set this working out that are appropriate. Certainly seen people do sort of the subtract 2 of the arrows here. You know, in the end, the working out is not the important part in terms of, as long as it's clear, it doesn't really matter how you work it out. You do have to communicate what you're doing though. So make sure your communication expresses how and what you've done. Now, let's have a look at another one. And in blue over here, another simple equation, 7x equals 11. And again, we're looking for that opposite or inverse operation, and in this case that's divide. So we're going to divide both sides by 7, and I can do this by just setting them both over 7. That's a nice easy way of doing it. Cancelling out the 7's there, of course I get x equals 11 over 7. This is the exact value, probably the best way to go. Maybe you could write it as 1 4/7. Go back and revise your mixed number, the top heavy fractions work if you need to. But of course this is also equal to about 1.58. You could write it as 1.58 as well, but as soon as we do that we've lost some of our clarity through rounding. Two-step equations. Now further to those simple equations, we could be looking at equations that involve two steps, two processes together, such as 3x minus 8 equals 11. Still a fairly simple equation and won't come out with the nicest possible answer, but it will still work nicely. So there's a couple of ways we could do this. We could divide through by 3, but that creates double fractions and then we're going to have to combine them. So the easiest thing to do is think about the x like it's a present in past the parcel. And so we need to unwrap the x. The 11 is the irrelevant part, but we have to unwrap that x. And I'm looking for the thing that's the furthest away, the most distant from the x. And in this case, that's the minus 8. So how do I get rid of the minus 8? Of course, I add 8 to both sides of my equation. And over here, when you're adding a term, you only have to add it once to each side. So, and this is the same for subtraction, of course. So I add to both sides. 3x minus 8, and I'll do the working out here. 3x minus 8 plus 8. So this is what I had, and I'm adding 8 to it. 11 is what I had, and I'm adding 8 to it. This step of working probably isn't necessary, but it really does help some people understand. They will cancel out, which of course is why we chose the adding 8. And we get 3x is equal to 19. And now I've got 3x equals 19, I need to divide by 3, my apologies. And so when I divide by 3, I can set it out like this. Divide by 3, I get x is equal to 19 over 3, or I don't mind saying 6 1/3. Of course 6.333, eventually I have to round it, so it's not quite as nice to leave it as a decimal. X on both sides. Now another type of equation we did say we could get is an equation that involves x on both sides. So let's talk about that, and I'm going to deliberately set this up with a certain result. So 2x minus 8 is equal to 5x plus 4. Okay, I'm hoping this will work out the way I want it to. Now, here's an important little caveat to a normal rule. So what tends to happen in equations is we desperately want to get all the x's over here on the left-hand side. Now, I do want to do that, but I'm wary of that situation because I know it's going to create a negative x. So I subtract 5x over to here, I get negative 3x. So it's actually not ideal. And where I can, I'm going to try and avoid negatives. So what I'm going to do instead is I'm going to subtract 2x. So my strategy now is to subtract the lowest number of x's in order to keep the highest number of x's positive. So I'll subtract 2x on both sides. It will cancel out those 2x's and I'll be left with negative 8 is equal to 5x minus 2x is 3x plus 4. Now it's not ideal, I know, because the x is on the right hand side. It's not normally where we try and keep it. But now, let's take this the next step and remove the 4, because we're unwrapping that present again. Subtract 4, And when I subtract 4 over here, negative 8 minus 4 is equal to negative 12, and this is equal to 3x. So 3x equals negative 12. We are going to get a negative answer irrespective now. So we divide both sides by 3 over 3 over 3, and we get negative 4 equals x. Of course, negative 4 equals x is not our natural way of writing it, so we just do a swap. Because if negative 4 equals x, well then x equals negative 4. Just be careful not to do anything crazy on that swap, like, I don't know, remove the negative from the 4, which is a pretty common mistake that some people will make at this stage. There we go. Equations with brackets. So we could also get equations with brackets in them. So let's talk about how we deal with the brackets. So there's a couple of ways we can do it, but let's say we've got 3x plus 7. We'll see some harder bracket ones a little bit later, but 3x plus 7 equals 15. Now I've deliberately chosen some elements of this because remember I do want to avoid fractions where I can. Now they sometimes they just come, but if I can keep them to the last step, we are much happier. But of course here, I can avoid fractions quite easily because I could do the expansion step, which is probably the most common way to go, and if you're unsure about these, it's probably the best way to go in all cases. But let's say I don't want to avoid the expansion step and I want to take one less step away. I could actually divide by 3. So we'll do this twice. If I divide this by 3, before I even expand, I get that cancelling out. X plus 7 equals 15. And that is wrong, so of course 15 divided by 3 is 5. So I get x plus 7 equals 5, I subtract 7 from both sides, and that gives me x is equal to negative 2. My alternate solution though, which is the one to go for, if you're not confident, go for this one every time. 3x plus 7 equals 15, and in my alternate solution here, what I do is I expand first. Because we don't like brackets being in our equation, so we get rid of them by expanding first. We get 3x from this expansion, and then plus 21 equals 15. And then we subtract 21, that's a 12. 21 from both sides, and that gives us 3x equals negative 6. And then of course we divide by 3 on both sides, because that is the opposite to times by 3, and we're still unwrapping this x, and x is equal to negative 2. And look at that. Same answer on both sides. So there's some options for you in terms of solving an equation with a bracket. So let's summarise. You've seen 4 particular cases here of types of equations and how to solve them. But realistically your aim should be to get fluent in solving any equation put in front of you. So listen, learn the rules, and then practice questions that are randomised in order so that you get used to picking the right rules to solve any type of equation. All the best.